application shows simultaneous dynamic signal input and output with National Instruments CompactDAQ and LabVIEW. In just a moment, we'll show you how to program this in LabVIEW, but first, I would like to show you our hardware setup. What we have are two microphones, and these microphones are going to be acquired with the National Instruments C-Series 9233 data acquisition module. Now, this is a 4-channel IEPE 24-bit module that can sample all 4 channels simultaneously at 50 kilosamples per second per channel. The microphones are read into this module, and we'll be acquiring them that way. We'll also generate a sine tone, and that's going to come from the C-Series 9263 module. And this is a 4-channel analog output module with a resolution of 16 bits, capable of all 4 channels updating at 100 kilosamples per second. We'll use that to generate a sine tone. What we're going to be doing is generating the sine tone and reading it into these two microphones. The time that it takes this sine tone to reach each microphone will be dependent on the position of the source itself. So in this case, where the source is closer to this microphone, this sine wave will reach here first. Then it will reach here later, and that delay will show up as a phase difference between those two signals. We're going to measure that phase, and then we'll be able to show you or point to the position of the signal source. So that's our setup. Let's now go into LabVIEW and program the application. The first thing that we would like to do is go to our front panel and put down a meter. So we'll click right, we'll go get a meter, and we'll put it on our front panel. We're going to scale this from -100 to +100 because our degree range is roughly plus and minus 80 degrees. Here would be 0, this would be about plus 80, this would be minus 80 degrees. That's all we really need to do for the front panel. Now let's go back to the diagram and begin putting our program together. First thing what we would like to do is generate our sine wave. So we're going to click right, we're going to go down to our Express VIs, we'll simulate a signal, and then we'll go and choose a sine tone. So sine is already selected. We're going to tell it we want to output at 20,000 samples per second. It automatically will choose a 2,000 sample size, and then we'll tell it we want to generate a sine tone that's at 1 kilohertz or 1,000 hertz. So we'll select OK on that, and that's going to be our sine wave. We'll be ready to go there. Next, we would like to actually do the analog output or output that waveform. So we'll go and get the DAQ assistant and we'll set it down. And then we'll tell it a few things. We want to tell it to generate signals. We want to do analog output. We want to do voltage. And then we're going to choose analog output channel 0. And that's this channel right here coming out of the 9263. Okay, at this point we'll tell it to generate continuous samples so that it'll run until we tell it to stop. And we would actually like to go and try it. And it's set up for sine wave as a default, so if we hit the run button, you'll see that it's generating our sine tone, and we have our output. It's coming right out the speaker, and we now have verified that function. So let's click OK on that. It will go and build that function, and then we want to actually wire this up. Now it's going to ask us a question if we want to put this in a loop, and we don't. We're just going to start this off, and it'll run continuously until the program stops. We'll take our actual generated signal and we'll wire it in, and we're ready to go with that. Now we would like to do the analog input. So we're going to click right again. We're going to go down to the DAQ assistant, and we'll put it down. At this point, we'll tell it we wish to acquire signals, analog input, voltage, but we want 2 channels, analog input 0 and 1. And those are the inputs right here, coming from our 2 microphones. So at this point we would like to tell it, again, we wish to acquire continuous samples, and then we need to set the sample rate and the number of samples. We'll tell it 256 samples, and we're going to acquire them at 40,000 samples per second. At this point we'd like to try it, so we'll click the run button, and as I talk we should see my voice pattern coming in here, and if I whistle you'll see some sine waves. And we do indeed see those coming in. So this has been confirmed. Let's go ahead and put this into our diagram. So it'll build the function, and we've gone and acquired our signals. The next thing that we would like to do is tell it to put it in a loop, yes, because it'll run over and over again. And this will be the main loop for our program. Now what we would like to do is a little bit of analysis on this. So we're going to go into our Express VIs, we'll go into Signal Analysis, and we're going to get the tone measurement VI. We'll put this down in the diagram, and it's going to ask us a few questions. We don't need to read the amplitude, but we do need to read the phase, so we'll select the phase, and then we'll click OK. So that's going to take our signal and give us our tone information out of it. Let's create a copy of this because we want to read this on two different channels, and we'll just put that down. It'll expand our loop out a little bit, and we'll be able to read the phase on our two independent channels. The next thing we have to do is split the two channels apart. So we're going to go into Express and Signal Manipulation. We'll split the signals, and we'll put this down, and this is going to let us take channel 0 and channel 1 and send them to our two separate tone measurements. So we'll just wire this in. We'll take our first channel and we'll put it into signals. We'll take our second channel and go to the second tone measurement into signals, and we're good to go. Now that we're reading the two phases, what we really want is the phase difference between these two channels. So this is a simple subtraction. So we're going to go get a minus, we'll put it down, and then we'll take the phase values that come out of here and we'll subtract one channel from the other, and that'll give us our phase difference. Now at this point we know this is very susceptible to any spurious noise, so I'd like to do just a little filtering, and a median filter is a really good choice in this case. So we're going to go down to our signal processing. We'll go down to point by point, into probability and statistics, and then here's the median here. So we'll get that function and we'll drop it in. So we want to send our signal, which is the difference in our phases, into that median. And then I want to maybe take 10 points and filter out any spurious things. And so we'll create a constant and we'll type 10 into this, and that's going to give us our value. Now finally, we're going to take that phase output and wire it up to the meter. The phase difference output gets wired into our meter, and that will be our program. We can clean this up with a quick Control U. You can see the program, and we're ready to run. Now before we run it, I'll describe what you're going to see, and then I'll just do it, because if I talk in the middle of it, I'll disturb the phases. So when I move this back and forth, we will see the difference in the phase for those two signals coming in, and we should see our meter point to exactly where that signal source is. So I'm going to go ahead and run it, and then we're going to see this run. And where I have it now is roughly at 0 if I have it in the middle. So we'll run it right now and see what happens. There's 0. We'll go ahead and stop that. So you've seen that we've generated our audio tone, and we've acquired our dynamic signals, and this is how you would do simultaneous dynamic signal generation and acquisition with National Instruments CompactDAQ and LabVIEW.